Welcome to Data Types and Structures. Every piece of software you have ever used, from a simple calculator to a massive multiplayer game, is just data being moved around in memory. In this unit, you will master the exact tools Cambridge requires you to build algorithms. We are going from the simplest single numbers right up to complex grids and permanent files. This is the absolute foundation of your Paper 2 algorithm design and your Paper 4 practical programming. We start with primitive data types. These are the fundamental, built-in building blocks provided by your programming language. You need to confidently select between integers for whole numbers, reals for floating point precision, booleans for true or false logic, and characters for single symbols. Choosing the wrong type in an exam question can break a loop, corrupt your memory allocation, or lose you fundamental method marks. We will look at exactly how a computer stores each one in memory. Next, we look at strings. A string is simply a sequence of characters treated as a single data item, but manipulating them is a massive part of your exams. You will learn to declare them, extract specific substrings, calculate their length, and compare them character by character using both Cambridge pseudocode and Python. These are the exact operations required to process user input and format outputs flawlessly. When you have hundreds of related items, you cannot declare hundreds of individual variables. Instead, you use an array. An array is a fixed-size, ordered collection of elements that all share the exact same data type, stored contiguously in memory. You will learn to traverse one-dimensional lists to search for items and then step up to two-dimensional arrays. By mastering nested loops, you will be able to manage complex grids, seating plans, and game boards without triggering index out-of-bounds errors. But what if you need to store a student's name, their age, and their grades all together? Arrays only hold one data type. For mixed data, you define a record. You will learn how to group different data types under a single identifier, creating custom structures that perfectly model real-world objects. Without records, handling anything more complex than a simple list becomes a chaotic mess of parallel arrays. This is essential for structured programming. Finally, we tackle persistent storage. Everything held in RAM is volatile, meaning when the program stops, the data dies. To save data permanently, we use files. You will learn the exact pseudocode and Python syntax to open, read, write, append, and close text files safely. We will trace file handling algorithms and build end-of-file loops, ensuring your data persists on the secondary storage disk long after the program finishes executing. By the end of this unit, you will have the complete toolkit to store, access, and manipulate data. You will know exactly how to declare primitive types, structure complex user-defined records, iterate through multi-dimensional arrays, and persist your results to text files. These concepts sit inside almost every algorithm you will ever write. You are ready. Let's get started.